Welcome to the presentation Exploring Android Apps Using Motif Actions. You all know how Android test generators work. Consider the main activity of a BMI calculator app. First, the test generator locates the actionable widgets. In this example, we can see a text label on the top, two spinner widgets, two input fields, and a button. Then UI actions are associated to each actionable widget dependent on the widget type. As one can observe in the example, we primarily associate click actions to the widgets and to insert actions for the input fields. However, current test generators lack the contextual knowledge. That is, they don't know in which order widget should be clicked or interacted with. For instance, if we directly click on the Calculate BMI button, we end up in an error state. The correct order would be to first insert the weight and height and then click on the Calculate BMI button. This would compute the expected BMI value. Inspired by the Sapiens approach that first spotted the idea of combining low-level UI actions in a specific sequence, we derived Motif actions as follows. We took 10 open source apps used in previous studies, extracted from them recurring UI patterns, and defined specific UI action sequences that trigger a state change. This led to a catalog of 12 distinct Motif actions. We have already seen one such Motif action, that is, filling out a form and clicking on the Submit button, and now we will consider two further such Motif actions. A very useful Motif action is called menu click and item selection. This Motif action opens the More Options menu bar, selects an arbitrary entry, clicks on it, and this is likely triggering a UI change. Many apps make use of such menu bar, and this Motif action is likely causing an activity transition. A very similar Motif action called Change Navigation Selection opens the navigation menu and clicks on the arbitrary entry. This likely leads to an activity transition as well, and most more complex apps make use of such a navigation menu. Now let's move on to the actual test generation. We essentially follow a random-based exploration where tests are generated until a timeout is reached. We start with an empty test that gets iteratively filled with action until a maximal number of actions is reached. The app under test crashes or an action leads to a state not belonging to the app under test. Once the test is complete, we perform some post-processing steps like storing the coverage of the test. Then we restart the app under test to ensure a clean state for the next test. The selection of the individual actions works as follows. We compute a probability for both UI and motif actions and then flip a coin. The probability for a motif action is controlled by the number of motif actions in the current state and a user-supplied parameter called alpha. In detail, the probability is defined as the relative count of motif actions in the current state to the power of alpha. Then the test is updated with the new action and finally executed. After that, the current state is updated and the procedure is repeated until the condition is satisfied. We were interested in answering the following research questions. RQ1. What is the best way to combine motif and UI actions? That is, we want to find the best value for the parameter alpha that controls how likely motif actions are selected in favor of UI actions. RQ2. Are the grafted motif actions generic enough to be applied to a large range of apps? Here we record for how many apps at least a single motif actions can be applied. RQ3. What are the effects of testing with motif and UI actions? Here we want to know whether the integration of motif actions is actually beneficial for the test generation in terms of activity and line coverage. We integrated our approach in the open source test generator Mate, whose sources can be found on GitHub. Mate is actively maintained by myself primarily and offers a large set of genetic algorithms as well as many strategies implemented by other test generators. Feel free to have a look at it and try it out. The evaluation setup for RQ1, what is the best way to combine motif and UI actions, looks as follows. We used 10 open source apps from previous studies and executed them with 12 different configurations. Each app was executed for each configuration for 1 hour, and this was repeated 20 times to compensate randomness. The 12 configurations were formed by varying the motif action weight parameter alpha from 0.0 to 1.0 by a stepwise increase of 0.1. These are 11 configurations, and the 12th strategy is configured such that it only sends UI actions and serves as a baseline. The results for RQ1 are described by the following table. For each of the 12 configurations, we list the achieved activity and line coverage, as well as a score based on tournament ranking. The score was increased by 1 if there was a statistical significance, that is a p-value lower than 0.0.5 was reported in terms of activity or line coverage between any two configurations and a specific app, and the Wager-Delaney effect size reported a value greater than 0.5. Based on this procedure, the configuration using a value of 0.6 for alpha appeared to be the best configuration. It achieved 10% more activity coverage than the configuration using only UI action, as well as almost 8% higher line coverage. This shows the importance of motif actions. We can also observe that almost any configuration except alpha equals 0.0 achieves a higher tournament ranking score than the configuration using only UI actions. This strengthens further the importance of using motif actions. Recall that the probability for selecting a motif action was computed by taking the relative motif action count in the current state to the power of alpha. A value of 0.0 for alpha implies that only motif actions were used in this configuration. Since this configuration achieves the lowest score among all configurations and even less than the only UI baseline, we can conclude that a mixture of UI and motif actions is necessary to properly explore Android apps. The evaluation setup for RQ2 are the crafted motif actions generic enough to be applied to a large range of apps. Looks as follows. We used 551 apps from F-Droid and repeated them 3 times with the best configuration according to RQ1. Each execution took 1 hour, and we recorded for how many apps at least a single motif action could be executed. The results for RQ2 were as follows. In 477 out of 551 apps, at least a single motif action could be applied. This corresponds to a success rate of more than 86%. We also investigated why for the remaining 74 apps no motif action could be applied and identified 3 main reasons. First, the app is too simple. For instance, the app has no form or navigation menu such that any motif action could be applied. Second, the app has an external dependency. For instance, the app requires another app to be present or a device connected through Bluetooth. Third, the app does not operate properly on the given emulator. That is, the app malfunctions in the emulated environment. The evaluation set up for RQ3, what are the effects of testing with motif and UI actions, looks as follows. We filtered out of the 551 apps those apps that do not contain any motif action according to RQ2, require some sort of authentication, and have less than 5 activities. This resulted in 109 complex apps, which we executed with the best configuration according to RQ1 20 times for 1 hour each. We also executed the only UI configuration the same number of times and recorded both activity and line coverage. The results for RQ3 are given by the following bar chart. For both coverage metrics, the motif-driven exploration achieves roughly 2% more coverage than the configuration using only UI actions. Although the difference is obviously smaller than on the 10 apps used for RQ1, a 2% increase is still beneficial in the Android testing domain. This brings me to the conclusion on some points that should be addressed by future work. We have seen in this presentation that plain UI actions are not sufficient to properly explore Android apps. The solution was to introduce Motif actions, which are specific sequences of UI action to fulfill some use case. For instance, filling out a form and then pressing the submit button. Then we discussed how we extracted a catalog of 12 Motif actions and how those Motif actions were integrated into test execution. The evaluation has shown that Motif actions are useful in the Android testing domain. But we have also seen that an effective exploration requires both UI and Motif actions. We have also demonstrated that the grafted Motif actions can be applied to a large set of apps, and that on a subset of more than 100 apps, they can increase both activity and line coverage by roughly 2%. Now points regarding future work. The catalog of 12 Motif actions is by no means complete. Every app is different and requires different interactions. Further use cases could be modeled by new Motif actions. Unfortunately, apps use different widget classes to represent the same app functionality, which makes it not always easy to extract a common UI pattern from which a new Motif action could be derived. And also the API to retrieve widget information is sometimes buggy, making it difficult to determine if a Motif action can be applied or not. Thanks for listening, and now I would like to answer your questions.